Arduino for Beginners, Episode 25. How to make a laser burglar trip alarm. Now, in the last video, we took a quick look at how to amplify our tones for the Arduino to make them super loud. Because for this, the just standard tones on the Arduino aren't really loud enough. And we looked at how we could use a Mosfet or a Darlington transistor to do that. Well, in this episode, I have the laser set up here. This is just one of the little 5-volt laser modules. You can get these off eBay, Amazon. They're only like $2, shipping included. And I've got everything enclosed in here. There's actually an LDR, a light dependent resistor. There's a hole in the side that sticks through, and the laser beam is shining on it. And then I'm using a Nano and Arduino board, and everything fits nice inside this little box. And after I demonstrate it working here, I'll open it up and show you what it looks like inside. But for the schematic and everything and the sketch we'll be using, just look in the description below. You'll find a link to this project's webpage, and there you can get all that information, plus pictures and anything else relevant to this project. So let's first here, I'll just demonstrate it working, and then we'll take a look at how it's all set up. So now I have this pretty close, but being we're using a laser, you could have this at a great distance apart, easily 15-20 feet without a problem. Just a word of caution and a disclaimer: do not use this anywhere around where you're going to have children or pets or anything where it's going to shine in the eyes, because we are using a laser. And if this gets shined in your eyes, it can permanently blind you. Actually, it most likely will blind you, if not partially. It might be totally. But if you decide to build this and try this out yourself, do so at your own risk. If you're under the age of 18, get parental supervision for this. Be careful. If you do decide to build this and use it yourself, do so at your own risk. We at the Z Hut here are not responsible for any injuries or accidents that happen. Like I said, this is for educational purposes only, and I'm showing you how it works, so, well, you don't have to. But, all right, well, here's a quick demonstration of it working. I'll just say somebody walks between and breaks the beam. I have the alarm set to go off for just a few seconds, and then it quits, even though the beam is almost instantly turned back on and let to see. We're just breaking it real quick, and it makes the alarm go off. And when we get to the sketch, I'll show you how that's done. I'll demonstrate it once again, and we'll take a look at how this is built. All right, I'm going to disconnect the power, and then I'm going to turn the laser off. Now the laser here, I'm just powering this off a 5-volt battery pack at the moment. If you were setting this up across the doorway or wherever you wanted the trip alarm, you're probably going to want to use a wall wart. Just make sure you are not putting more than 5 volts to this. Now if the wall wart says 5 volts, you put a voltmeter on it, it's going to probably be closer to 7. You're going to want a wall wart that probably says 3 volts, and that should work fine. Otherwise, you're going to want to use a voltage regulator or something of that order. And that's actually what I'm using, a step-up converter with a battery pack. Right now, I'm only got like 4 volts going to the pack, but it's stepping it up with the voltage stepper-upper to 5 volts. And like I said, these little modules can be purchased on eBay for under $2. You can find them on Amazon as well. And that's shipping included. From overseas, if you buy it here in the U.S., it's probably going to be like $3 or $4. They're a little more expensive, but... All right, so there isn't really anything to go over to that. There's just a positive and negative. You hook power up, the laser's on. So I'm going to move that out of the way. Bring this in here. Open it up quick. Now, instead of just using a speaker, you could also hook up, I built one of these before, and I used an old car alarm horn. And when it was triggered, I just used a Darlington to turn that on. You don't actually have to use tones with that. The tone siren is built into it itself. But this is nice and easy. You just need a little speaker. and everything fits in this nice little box. We got the LDR right here, and then we got a power plug right there for a wall wart. So we open it up, and you can see that's all we got. I've got my Arduino Nano, I've got the LDR, and we have this set up as a voltage divider, and I believe I'm using a 10K resistor with my LDR and doing a voltage divider. You might need to use a slightly different resistance. You got to play with it a little, and in the sketch we have it set up so you can monitor it and see what your values are. But different LDRs require a different resistor. Most commonly around a 10K, start with that, and you should be, most likely you're good to go there, but it does all depend on the LDR you're using. Then I just have, on the last episode I used a Mosfet. Well, this time I just swapped it out to show you a TIP120 Darlington. Works just as good, so I swapped that out and put this in, one of them in this time. And then we just have the power coming in. And to see the full schematic on this, like I said, look in the description below. You'll find a link to this project's webpage, and you'll find the full schematic on there, parts list, and substitutes you can use and whatnot. So, all right, with that, I think we can go ahead and go over to the computer, and we'll take a look at the Arduino sketch that we were using to control this. Yeah, I can't think of anything else to go over, so I will fire up the computer and bring up the Arduino IDE. So I'll catch you there in just a moment, and we'll take a look at the code for this. Okay, I have the Arduino IDE opened up here and the sketch loaded in. As you can see, this is a pretty simple sketch. This is the whole thing right here. There's not a whole lot to it. So to start with, the serial.begin up here, this is just for testing. Once you figure out your voltage divider with the LDR, you can actually just comment that out. And the same thing right here. We're just doing a serial print to the serial monitor, so you can monitor this computer, see what your readings are. You're going to want, with the full light on your LDR, with the laser light on, you're going to want it to be as close to the 1023 as you can get it. And then I have it set, if it goes under 600, it sets it off. I actually found if you're going to be using this out in a daylight application outside, you're going to want to have this probably closer to 900. As long as it's not pointed, the sunlight's not directly hitting your LDR, you should be okay then at the 900. You might have to play with it. You might actually have to go up to 1,000. I think when I had mine set up, I was monitoring it. I was getting like 1,015 or 16, somewhere right in there. So if you set it at being triggered at 1,000, you'd probably be okay. But once again, yes, right here, you can just comment that out. That's just there for testing. So in the void loop here, we're doing as an integer, and we're reading the analog pin 3, and that's where we have the LDR, of course, set up as voltage divider. And the reason we do it as a voltage divider is you get better, stable readings if you just try hooking it up direct, not doing it in a voltage divider. It doesn't work very good. I'm not really going to go into it. If you're curious about it, just try setting it up. You're not going to hurt anything. Just set it up without the voltage divider and play with it yourself, and you'll see what I mean. It just doesn't work very good at all. Then we're doing a delay of 10 milliseconds. That's plenty. Actually, I wouldn't go any higher of a value. You could probably even do 5. That's more than enough time. I mean, if somebody is running through the beam, I mean, it just takes an instant. So between 5 and 10, you'll be fine. Now what we're doing is right here, this is where you put the value where you want the alarm to go off. So if the value that you're reading from the analog read on, did our analog pin 3, you can use any of the analog pins. If you use a different one besides A3, just change to that number and that'll work. But I've got it set here if the light value goes below 600. Like I said, you might want to put it closer to 900. If it goes below that, then we're going into a for loop, which is triggering the alarm, and we're doing that so the alarm goes off instead of just one beep and then, you know, the beam is broke one beep, you're probably not going to hear that. If you do, it just makes it easier to have the alarm to go off for an amount of time. I have it cycling through 25 times. Actually, if I was setting this up myself as a burglar alarm, I'd probably have it go through this several hundred times, maybe even 1,000 times, to really let the alarm go off long enough to, you know, notify somebody. Well, the laser tripwire burglar alarm's been tripped. But the reason I'm doing it this way is so it doesn't just go off continuously. That might upset the neighbor if my cat accidentally got in the garage and triggered this, and the thing was going off all day or all weekend when I wasn't at home. So that's the reason to do that. It's up to you. The longer you want it to go, just increase this number right here. Then, of course, we're doing a tone, and we're just setting that on, I've got this set up on pin 3, and you can use any of the digital pins. Just change that number if you use a different one. And I'm using a tone of 400, and I'm doing a duration of 100 milliseconds, and then we're delaying, so it gives it that the alarm tone instead of just being a constant tone. And that works out pretty good for me. So you can go ahead and play around with this, have some fun with it. You can actually even do a two-tone alarm where you have the delay. You have a delay, and then you have a different tone, so it kind of sounds more like a police siren or something. So you try that out as well. Have fun with it. Do whatever you want with the sketch. But I think that's all there is to really go over on this. It is pretty easy. So if anything didn't make sense to you, maybe try checking out the under the help. There's the resources if you're not sure what the for loop is, how it works. And by this point, if you're following this series, you should know what the for loop is and the tones and everything. But all right. Then just a quick reminder again, all the sketch and the schematics, everything, just look in the description below. You'll find a link to this project's webpage. All that stuff will be on there. So I would like to thank you for joining us here today. I hope you have a great day. And remember, have fun building.